Okay, let's start. Welcome everyone to senseFly Academy today. Today I have with me Adam Zilka from the US team and Michael Blake from the support team here in Switzerland. How to measure inside Pix4D in a process data set, how to get an accurate measurement, and how to flight plan so that your measurements are becoming as accurate as possible. How to measure. First of all, you need to process your data set. Initial processing, all of it for sure. Second step, you mainly need a point cloud. You don't need a mesh. So densified point cloud, and you also need the DSM, the digital surface model of the third step, especially for volume measurements. Okay, means you can deactivate the mesh generation and also orthomosaic and any index calculations if you're only interested in measurements. In Pix4D, you can measure polylines or lines, surfaces, and volumes. Let's start with the lines. And I have a nice data set here prepared for you. You can see all three steps are prepared here. If we go into the processing option, DSM orthomosaic, the orthomosaic here you could, for example, turn off if you don't want it to process. Or in the second step, 3D texture mesh, just deactivate if you don't need it. Then the processing is a bit faster and you're faster ready to do your measurements. Good. Once this is ready, you go into the ray cloud view, you activate your densify point cloud, okay, here. Voila. Might take a moment to load now since I've already loaded it. It's fast. You see we have here a little construction zone, and now I'm interested here, for example, in the distance between this part here to the little river down here in the ditch. For measuring this, I go up here, I grab the polyline tool. And now I place left-clicking my first point. Of course, I can now click as many times as I want, left-click to place a point, but now I just want 2 points. I want it down here, and I right-click in order to finish my line, okay? Okay, good. Sorry, I had to arrange slightly my screen here in order to better, there we go. So I took the measurements and right away I have here on my left-hand side the images. Sorry, the measurements. And now my images should show up. There we go. A little bit slow today. Good. So we have a 3D measurement of my line as well as a 2D measurement, 21.5 meters, more or less. Now, the error we get by adjusting the position of the 2 points inside the images. This is, you scroll into the position, we choose here the bottom of this rock for this point. And here we select here this part of the shadow. This is, of course, a bit difficult if you're working with these kind of nature objects. You have to repeat the process in at least 2 images for all points if you want that error measurement. I think I put it here. Okay, then we click apply, and now you get your error measurement. So that's around 16 centimeters on the 3D length and 5 centimeters on the 2D length. We can copy all this data to clipboard and save it somewhere if that's necessary. The line itself, we can go and right-click it, and then we can export as KML or shapefile. So you could use this feature also to digitize, although I imagine it might not be so straightforward. Good. Now, next part, surfaces. Basically, same thing. We are taking the measurement in the rake cloud on the densify point cloud. New surface. And now, for example, we want to know how big is this construction zone here. So you left click again to place a point. It's always good to zoom in if you want a good measurement. It's good to place several vertices and not just one or two, except for the lines, of course. Now we're being a bit rougher here in order not to take too much time, but in general, it's always good to really use your mouse and scroll in and out in order to gather your points. Right-click to close your surface, and you get right away the measurements on your right-hand side. For the error, again, you would have to go into the pictures here and position every point on at least 2 images. The surfaces do have some other purpose as well than just measuring. You can see here you have two options. Use for DSM and triangle mesh, automatic orientation. By choosing those or activating those, you can correct areas in your DSM, respectively in your orthomosaic and in your triangle mesh, where your point cloud is weak. Like, for example, in this data set here, where you have the lake or a lot of vegetation, or you have a bit of holes here in the 3D cloud, point cloud. And this you could fix. This might not look as nice in your orthomosaic or in your triangle mesh. By putting a surface over an area like this, it will nicely project the image onto that surface, which will just be assumed to be all flat, and therefore you will be much nicer looking in your orthomosaic or 3D mesh. Good. Now from there, surfaces you can also export to KML shapefile. Just right-click on your surface object and click on export. Now for volumes, we change the view. We're not in Ray Cloud anymore. We click on volumes. It will automatically load here the densify point cloud for us. Now you see here I've already been playing with some volumes. Voila. We don't want to see this first one because we're going to do it from scratch. In order to start drawing your volume, you click here on the plus. Remember, the volume measurements depend on your DSM, okay? So you need to have your DSM processed. What I'm doing now here is, I am drawing a base surface around my object. It's always good to go closer. The less surface you have around your area, so the less green you see around your object, the better and the more accurate your measurement. But careful, you also don't want to get too close and cut off parts of the pile here. You really just want to make sure to nicely outline. Right-click to close. And now on the left-hand side here, you click on Compute in order to calculate the volume. You get right away, you get your volume measurements where the cut volume here is everything above your base surface. The base surface is always green. And the fill volume is everything that is below. Where this is very little, volume in this case, just because we may have one or the other point that lies below the surface that gives us this little error. Again, we have this error measurement, which is maybe 2 or 3% of the whole pile. So pretty good. Now, this is very easy here to measure a surface. The terrain around this pile is very flat, so not somehow in a weird position with the terrain around it. Now it can be that it's a bit more complex, and then you can actually simply adjust your base surface. Your base surface, once you've drawn it, like I just done before, you can tell it to either fit between all the points that you've been drawing, or align with the average point, with the average altitude of all your points, align with the lowest points of your base surface, or align with the highest point or custom altitude. I'll change now custom altitude. I'll make it 4. I say OK. Now if we go and look what happened to our surface, you see my base surface was lifted up, and my points that I've been drawing are not relying anymore on the point cloud. The trick is that you can only place, while you are drawing the outline of this base surface, you have to click on the points in the point cloud. It will not let you draw them into the empty space. Therefore, you'd have to adjust the base surface like I did now after you finished your surface. Once you click Compute Now, voila, you can see, of course, now our fill volume is much bigger because we lifted up our base surface from the ground. All the data here can be exported to clipboard. You can also export the outline of your surface to KML or shapefile, just up here, or also import. If you're working in absolute accuracy over time and you're always mapping the same area, then it's very likely that you can reuse your base surfaces. Good. Then one more thing I'd like to add for volume measurements. So it can be that you have something on top of your volume. Okay, so here, this is a nice example. We have this machine here on top of the pile. If we now would measure our volume, this machine is going to be part of the measurement, which is obviously not what we want. What you'd have to do, you have to click here on Edit Densify Point Cloud, click OK, and then you can mark points. Now I'm just quickly showing out here in the river. Then I assign those selected points to deleted. Okay, and now if I uncheck here, you see the machine actually, I did already in order not to waste time now trying to select these points, but you have to assign them to the deleted point group. Then you go into processing and you process only the DSM again. You really need to reprocess that DSM again, and then if you go and do your volume measurements, you do your volume measurement without that crane or without that machine on top of the pile. Okay, so now you've seen how this all works in the processing software, and you see it's fairly easy to do compared to traditional methods where you would put laser scanners or rover stations in different positions trying to collect as many points as possible. So this will take much longer. There's more work in the field. At times it's hard to geo-reference that data, where using a fixed wing of senseFly or Albreeze, it's going to be fast data collection, fast processing, and if you're using RTK PPK on top, you actually get a super good accuracy of the data set, which is also improving the accuracy of your measurements. Now, how to flight plan or how to make sure that you actually get the accuracy of your measurement that you're looking for. A good measurement is based on a good data set. In this case, we're looking for a high GSD, so lower numbers of resolution. With the SODA camera, for example, that would be 2.5 centimeter per pixel. And we need a good point cloud density, so good overlap, enough images for sure. Means we have to plan our flight well. Of course, we adjust the resolution. Overlap, actually, we don't need to adjust that much. Emotion Free has by default a 70 to 60% overlap for the SODA camera on EB+, which is enough. What is more interesting to do than increasing here the overlap is to either choose perpendicular flight lines or reverse flight lines. Of course, flying the whole mission in RTK PPK precision will also add your data set. And don't forget to adjust your flight lines to the terrain. So if you have a slope, put your flight lines parallel to that slope. Here is such an example. Here we're flying parallel to the slope. We leave those settings alone, the overlap, but we're gonna use reverse flight lines. So after you fly the mission once, and then you repeat it, reversing the flight. That way, the drone is flying the opposite way, the flight lines, and therefore you get your pictures at slightly different angles, which is already enough to generate a super good data set with a lot of image material and information that the processing software can use to generate the 3D point cloud. You can see here we're also using RTK here through the base station. Of course, the option of perpendicular lines is not practical here, since you would have then your lines here pointing towards the slope, and which will make them be at just above ground, like not adapted to the terrain change, and therefore you will have different distances from the pictures to the ground, which will give you different resolutions, and therefore a mix of GSD that will not necessarily give you the accuracy that you're looking for. Bye everyone, thank you for joining.